Hello students. Now we are trying to learn some of the basic concept of linear data structure, that is linked list. Here we try to find how it would be managed and how it will be stored in memory. These are the content we are going to go through this video lecture, that are introduction, then after how it is important and what is the advantage of this. SLL means SLL means it is talking about singly linked list. It is a basic linked list where you have one pointer. Now, let me try to give you the brief about the linked list. Here you can find this type of architecture where you have one node. This node are being created by using some mechanism that is here. You can see it is a node having data type. These are been created with the help of one integer and one pointer. Now what is this info and what is this link? So info is the part where we are storing the value and link is the pointer to the next node. When I say pointer means what? Start means the starting pointer. This pointer point to the start of your linked list. Let me call it N1. Okay. So node 1 is here and node 1 would be pointed by our start pointer. Some value X star will store in this first node. This first node are now point to the second node. Okay. So that second node address would be stored in link part of your here address would be stored. Fine. So this way normal linked list you can imagine. Now for the memory, what will happen? Here you can see what was here. This is the nothing but your head pointer, or you can say start pointer. So it will give me the location where my first node are, where it is at position 22. This is the position. So here I can find my first node. So if I come here, I get the value S, and the link says the second node are at location 54. So where is my 54th location? There you can find your second node. Likewise the third node. Now you can see this at the last node you find nothing to point. So what they store in the last node, they point to null. So every time in a linked list, last node will point to the null. Now what is the advantage of linked list? Why we are learning this? Why we require this? First of all, definition itself says it is a dynamic structure. So what you can say, dynamic means that memory would be able to allocate as well as deallocate at the time of execution. So it is a runtime allocation. So memory will be more efficiently utilized here. Is this fine? Now the thing is, what is the second advantage? As you all are aware about the array part, array have the continuous memory allocation. So if something you require to add in between, then all the rest of the element have to shift backward. So there are a more operation required when we are trying to insert. Same way for the deletion. But here you just have to point the new node and the rest of are same as it. So here insertion and deletion are the operation which can be easily addressed in a linked list compared to your array. Now what are the disadvantage of using linked list? First of all, linked list is a continuous memory allocation chain. So you are not allowed to do the random access. Okay. Now what was the other disadvantage? As you see here, you require to store the location. So you require the extra memory for storage of pointer. Yes or no? Now what is the last disadvantage? If I have to explain in this PPT, that says it is difficult to traverse in reverse. Why it's so? Because if you are at the node 10 and if you want to come to the node 9, do you have the address of node 9? No. For a singly linked list, it is very difficult to directly jump to your reverse node, or we can say previous node. So what you can require, you start with the first node and then after count each and every node and reach to your destination. So here extra processing are will require if you want to do the traversing. Now, as it is showing that we have to traverse in our singly linked list, and we have two part, one is info and second is link. Check if my existing particular variable are pointing to null or not. How we can check? We first set our that variable with the value of start. Start में जो भी address होगा, we are trying to copy that part in our temporary variable. Now, after doing that, we are executing one loop. Here, what execution are doing is they are what these are saying whenever I want to jump to the second node. For that, I require the address of that second node. Let me make you more sense through this example. Here, one start pointer pointing to the node 1 and 2. Now, temp will move as well as I will make the correction. जैसे ही अब मैंने लिखा कि temp is equal to start, temp are now also pointing to the node 1. And then after, in coming in the loop, you can also use the link word. Link of your temp. This will give me address of my, this will give me address of my node 2. Yes or no? Is this fine? So this way you can traverse throughout your linked list. And in between, whatever operation you like to perform, you like subtraction, you do that part. If you want to make the sum of all the information, you can do that part. You have to stop when you are reached to the last node. Okay. Now here important thing is, here some example are being given when you have to add a new node at the beginning of some existing linked list. Now here take one operation. This operation says you have to add new node in existing linked list. What is my existing linked list here? My existing linked list have the value DGM. How can you come across this? This is the DGM only by looking at the first pointer. Where you can find your first pointer, this. Okay. This pointer says your first node would be at 103. Where is my 103? Here. So first element would be my D. Okay. After this is my node 1. What was my next node at location 106? So it is my node 2. Right? And this will point to this location 103. So this is my node 3. This linked list only have 3 elements and the last element point to the null. Now this is new to you. What is this? This is the availability stack pointer. Now, one operation we have go through with in this video only, that is we are trying to add some new node in existing linked list. For this, let me introduce what is this. What is this? Here, what you have to understand what was given here. Here, two array are being given. First array name is info and second is link. In info part, value are being stored. And in second part, pointer to the next node would be stored. Have you understood what value are being stored here? This pointer point to the first node. First means your head of your linked list. It pointing to the which node? This point. So here our first element are been there. अभी कहाँ यहाँ पे वैल्यू है d है, ठीक है. Now d के बाद आएगा j because the value 106 are stored here. Then after m would be the last value. Now what was the task given to us? We have to add m% in front of your my name. How can we add m% in front? What operation we require to do? Insertion. Okay. For insertion, first you have m%. Any random place is okay to add m%? No. It is not a good practice to put random because every time not possible to get the free space. So for maintenance of the free space, we are making one linked list with the help of availability stack. What do you mean by availability stack? Availability stack means it is a link of node where you can find all the free space. Here you can see 102, 104, 107 and 8 are the free space where we can add my what they are having. They have the availability pointer pointing to the node 102. 102 are pointing to the node. This node are pointing to 104. So 104 के बाद आपको कहाँ पे फ्री स्पेस मिलेगी एट लोकेशन 107. 107 के बाद आपको फ्री स्पेस कहाँ मिल सकती है? It pointing null. So this is the last available free space. After having allotment of 108, we don't have any free space. Understood? Now, for doing all this operation, we require some step to follow. While we are inserting, first step is to check the free memory is available or not. Checking if my space is free to insert something or not. How can I get this thing? कैसे पता चलेगा कि if I have some free space or not? By checking avail pointer. If my avail pointer are pointing to the null, it means no free space are available. So if something is not been available to add in our linked list, so what we can do? We just return from our operation. Fine. What is the second step? Second step is create new space. What they are saying? Create new space. कैसे new space create करोगे? By having extra pointer. This new pointer are being created and this pointer value are being copied from availability. यहाँ पे जो भी होगा avail में that value will be stored in our new pointer. So what do you mean by this? The new thing which are going to be added in our program would be copied here. This become my new node and this become my part of my linked list. So now it is not a part of free space. So if it is not a part of free space, we require to remove that from availability stack. How we can remove? By changing the value of avail. How we can change the value of avail? Avail value will be changed if I this operation. If I do this operation, I am able to modify the avail pointer. What do you mean by this? Avail are been pointing right now 102, and 102 link part is 104. So this 104 should be copied in my avail. So here I will modify 102 to 104. Okay. So what will happen? Now availability stack would point to 104. This will point to 104. This is my creation of new node is my second step, and removing the node from the availability stack is my third point. And what is my fourth point? What is my fourth step? Fourth step is to initialize. We have to initialize my new node. How we can initialize? By giving them info as well as link part. What would be here? यहाँ पे आप क्या डालोगे? I will add x. X contain the value ampersand. So ampersand would be copied. And what would be the link of the new node? As we are saying, it have to be add in starting. Starting में add करना है. तो अभी जो start node है, जैसे कि ये start node है, T is my start node, ठीक है? And it is pointing to the next node. Likewise, but now I have to add something in front. तो मुझे यहाँ पे ये चीज ऐड करना है. So what can I do? I will provide the link of my first node. And where is the first node address would be stored in my first. ठीक है? So what would be here? Clear or not? This is my fourth operation to initialize their info and link part. Now what is the fifth point? Now everything is ready. Our new have value 102. Avail have value 104. But we have to modify this first part. Now starting node is not 103. It is now 102. Okay. Now we have the value ampersand in front of my first node. So this is the fifth operation that I have to modify the value of first with the value new. Whatever store in new, I have to copy in first and return first. Is this fine? This way I modify my linked list, and whatever value are here I am giving to my first node, and I also modify the availability stack. So every time some new node try to add, first of all you have to check the availability stack. If it says null, it means you have no space to add something. So you just have to return from the first step.
Here we end our video lecture.